working on marine energy, and that's a topic we're going to talk to you about today. And we have some distinguished speakers as well for you today. So for the physical attendees and also online, I would like a warm welcome to 4 speakers. So next slide, please. That will take a few seconds. Okay, so we'll first start off with a distinguished guest, Hessa Abdullah from Shell. And she will explain actually why we're here at this Dutch pavilion that's all focused about the nexus between water, energy, and food, and why marine energy fits in that so well, and what perhaps maybe shed light on the opportunities she sees. Also, we have some developers to talk to you about the most recent developments within this booming sector. And the first speaker is Benjamin Lehner, my colleague. He is the project portfolio manager, and he's a former researcher at NASA, the European Space Agency, and TU Delft, and now works on a very interesting project he'll tell a little bit more about. And then the floor is off to Peter Hack. He is the managing director of the Pure Water Group. He's also working for WETSIS and as a chairman of the, in the supervisory board, and the chairman of the board of Redstack, and that's the company he will talk to a bit more about today. And finally, Jean-Christophe Allot from Tucardo. He will be joining us virtually. Hopefully that will all go well, and he can talk a little bit about Tucardo, the tidal energy. So warm welcome to all of the speakers, and thanks again for joining us. And thanks again to the Dutch Pavilion for having us. Next slide, please. Well, the attendees have seen it when they entered. You can see it on the screen behind me. We're here at the Dutch Pavilion, where the nexus between water, food, and energy is not only the topic of discussion, but it's actually physically here. We can see it in front of us. It's a beautiful, beautiful project. And we're very happy to be given the opportunity here to speak, and that's all because of the Shell Nexus Award, where, Shell will talk a little bit more about after me, so I won't go into that. But I do want to give special thanks to the Netherlands Business Council. They've been very helpful in preparing this event, and we're very grateful for all of their help. The embassy, of course, they've been very helpful, and thanks again. It's a great honor. And now, without further ado, I give the floor to Hessa Abdullah. Thanks. I'm so sorry.
Thank you. Good morning, everyone. Thank you for joining us today. So I'm Hessa Abdullah. I'm the head of corporate relations for Shell in the UAE. And as you know, that Shell announced its partnership with the Kingdom of Netherlands last year as the national partners for the Netherlands Pavilion. Shortly after that, the Netherlands Business Council, of course, found us, and they wanted us to partner with them as well. As most of you know, if you're from the industry, that Shell has committed to the Paris Agreement, so is other national oil and international oil companies. And we cannot reach that goal without working together as government entities, as private sector, as policymakers, and of course innovators like the DMEC. Our support for the Netherlands Business Council's Nexus Award came as part of that package, because we need to support companies who are making change. The winners of the awards last year, the Dutch Marine Energy Center, I'm sorry, I'm reading because I don't want to mess up your name, won this award because they have provided evidence that they can harness abundant energy from the marine tidal waves. And of course, the proposal had so many insights on how they can mix both marine, solar, and wind energy together in order to harness that energy. And if it was, of course, done in a larger scale, it can has great potential, a huge potential to change how we look at energy in the future. So without further ado, I'll give the floor back to the DMEC, the winners of the award, and wish them all the best and good luck. Thank you.
thanks again for the kind words. And I give the floor now to Benjamin Lehner from the Dutch Marine Energy Center.
Thank you, Sander. And also from my side, a dear welcome to everybody. I will present today a little bit about the new wave of renewables. So what is the new wave of renewables and what is marine energy in general? Next slide, please. By now, we all know the change to renewable energy from more traditional sources is unstoppable. We see a continuous increase on policy goals on the one side. So, for example, here a quadrupled, the amount of countries quadrupled which have a clear renewable energy target between 2005 and 2015. But we also see, like on the business side or on the private sector, that just the installed capacity and the energy the electricity generated from renewables is rapidly rising, and also the new installed capacity rapidly rising and overtaking more traditional sources. And this is a great development. And in this great development, next slide please, we also have marine energy. It is a part of it. Marine energy harvesting really the abundant electricity which is stored, or the abundant energy which is stored in our ocean in many, many different ways and paths. And here are just a few examples of recent news articles where we really have a floating wind wave energy project in Ireland by a big project development, Simple Blue Energy, who is performing that. We have the One Wave energy project in Israel, where EDF is working on, for example. We have a huge tidal turbine now in the water in Scotland with Orbital Marine and also with others. So we see a lot of these developments getting traction and getting news right now. And what actually, I mean, I'm talking now already about it, but what is this marine energy I'm talking about? And to make this a little bit more clear, we have a short movie for you. So I would ask, please, the operator to start it.
I'm here when the sun's not shining and the wind's not blowing. I'm always at your disposal. What if I told you I'm invisible? Want to get to know me? I am marine energy. Energy created by the oceans, seas and rivers. I use the force of waves to power you. Driven by the moon, you can extract me from the tides, ebb and flow. But there is much more to my story. I can be made from heat gradients in the ocean by pumping near freezing water to the tropical water surface, or from places where salt and fresh water collide. You can find me in marine energy farms, in existing infrastructures or in harbors, on offshore platforms where I create green hydrogen. I partner in coastal protection projects, and I live in remote places off the grid. In case you're wondering, I'm open for business. I work with governments to upscale their green infrastructure, with investors and with offshore companies. My people are frothing with ideas, and my companies are developing an extraordinary array of devices, because more and more nations and businesses are discovering my potential. There's a lot of weight on my shoulders right now. But with my good friends Solar and Wind, we are up for the challenge. Marine energy, the next big thing in energy.
Thank you. So, just as a bit of an impression what we are actually doing, I will now also guide you a little bit more through the technologies, through this new great opportunity which comes with these technologies. So as you heard in the movie also shortly, marine energy is wave energy, so generating electricity out of the waves of the ocean. Tidal energy, so basically utilizing the tidal force generated by the moon around the Earth to harvest this electricity in our ocean as well. Ocean thermal energy conversion, or in short OTEC, where you use the hot water on the top of the water column and the low temperature water in hundreds of meters of depth, and you exchange these two water columns and generate electricity by it. Salinity gradient energy, where we will hear a full presentation about later on, where you use two water flows with fresh water and salt water, and the ion exchange generates electricity. And also our friends, floating offshore wind, where you have the wind turbines installed on a floating platform outside in the ocean, and floating solar energy, which are not per se marine energy technologies, but we are working a lot with them. We are helping them to mature as well. Next slide, please. And all of these marine energy technologies, so salinity gradient, OTEC, wave, and tidal, share a few unique properties. So first of all, they are renewable. They are they're generating electricity from purely renewable sources. They are reliable. We know for waves, we know for tides, we know for salinity and for OTEC exactly when they will hit. For waves, it's a bit more tricky depending where you are in the location, but in general, you can predict it much better than wind and even solar. And they are powerful. We have a huge potential around the entire world of these marine energy technologies to deliver a lot of additional electricity to our grid. Invisibility, we see where we install, we are from the Netherlands, so we see a lot of wind farms already outside our doors, on land, offshore, both. And both already cause troubles as well, because people are often not accepting that there is a huge wind farm in front of their garden or in front of their view or at the beach where they go for recreation. So it's very important to have also electricity sources which are invisible to the general public to get the acceptance for it, because it can devalue house prices, it can change the recreational part. So this is an important part there as well. And as I said, it's powerful, it generates a lot of electricity and can also be scaled up to large scale worldwide. And let's go to the next slide, where I have a few examples of it. So here you see one tidal turbine from CIMIC Atlantis, so tidal energy which can be installed on the seabed. So these turbines are really mounted down in the sea, on the seabed. There is a tidal energy farm in Scotland already from Megan Atlantis. And that's one of the turbines which is installed there. And it's also an international or a European consortium working on that. Then the next slide, we will see the floating turbine. So I already mentioned this shortly. It's a floating turbine with two huge rotors, megawatt scale, and electricity production. As said, tidal electricity, perfectly predictable. You know in the next 10, 20, 30 years exactly when you will produce how much electricity. And this just floats on the sea surface and is mounted then down to the sea ground. And on the next slide, we see how tidal energy can also be integrated with infrastructure. So now we were talking a bit about having a tidal farm, but you can also include these technologies, not just as a tidal farm, but you can integrate them in coastal protection infrastructure. So what you here see is a picture from the Netherlands where these tidal turbines are installed at one of the water outlets or the water control system in the Netherlands. And the tidal turbines can go in there, so when you let water out or when you control your water flow, you can at the same time produce electricity. So it's a perfect example for a multifunctional system which can help you not just protect your coast, but also basically generate electricity. And also Torquato is giving a short 10-minute presentation in a bit. On the next slide, we see also that these technologies can take a bit of a different shape. So this is still a tidal turbine system, but this tidal turbine system is a so-called kite, an underwater kite, which can utilize even lower flows of current. So even if the tides are very weak, this can still work. And that's a perfect situation of these kites which move around there in the underwater. It's from Sea Current, also a Dutch company here. This can, for example, power islands. So, for example, the Dutch islands in the north, there is now an installation ongoing to power one of these island Ameland with the Sea Current tidal kite. So that's another example of tidal energy and how it can provide also communities or off-grid solutions. So all of these tidal examples. Let's now move on to the next slide where we see a bit of wave examples, or a few wave examples. So the first one here is an impression of a wave park. This one sadly does not yet exist, but we are working hard on getting it. It's an impression from Core Power Ocean, a Swedish developer, and they are planning this wave parks with large floating structures. On the next slide, we see also an example of another Swedish developer, EcoWave Power, so Swedish-Israeli developer, which is producing electricity directly on wave breakers, right? So you have, for example, a port, or you have just some infrastructure so similar to what we had with the tidal turbines. You can also have it here on the wave breakers, and the waves which come there to the coast, let's move the systems up and down, and that generates electricity, which is, of course, helping to safeguard the infrastructure, but also, again, generating electricity, so a dual benefit as well. And on the next slide, we have also the co-location with wind parks, and I want to just spend 1 or 2 minutes I know it's a lot of impressions right now, but I want to spend 1 or 2 minutes to really dive a little bit deeper into that one, because we just started a project on the co-locating with wind parks. So in this case, we are talking of co-locating wave with wind. I mean, the picture is speaking, so the small little dots are so to say, the wave parks. I mean, we have to see, of course, the wind park is 300 or 200 meter turbines, and the waves is like 30, 40 meters of devices there. And this co-location can help us to, of course, save space. I mean, you have to imagine if you put a wind park out, you put these wind turbines in a certain distance, otherwise they would produce a shade to each other, so you cannot produce them too close. So there's a lot of space in between these wind turbines. So one of the benefits, or one of the things you can do with this additional space, is put wave or also floating solar devices in between. At the same time, while doing that, while putting these wave devices in between the wind turbines, you can use the same electrical infrastructure. This, of course, comes with challenges because of many technical challenges which we have to overcome still, but it's really easy solvable challenges if you demonstrate it in a full-scale system. And that's what we are actually also planning to do. So in Portugal, we are installing now with the Swedish developer and with EDP, the owner of the wind park there, so EDP and Engie, for those who know these two companies in ocean winds. They are having a wind park there, a floating wind park, Windfloat Atlantic, and next to this floating wind park, we're installing the wave devices, and we're plugging them in on the same export cable. So we will install them on the same export cable. We'll demonstrate all this electrical infrastructure we need to plug these two sources together. And we do the same also with floating solar in Belgium, so where we plug in a floating solar farm, 3 megawatts, so that's 2 football fields, so 2 soccer fields for Americans in here, 2 soccer fields of floating solar with a wind park from Parkwind, actually. And that goes back to the shore. So that is a bit what we are right now investigating in projects, and that's also why I want to spend a bit more time on this. Happy to talk about that later in the break. The project is called EU Scores, and it's one of the DMEC projects we are working on. But let's go to the next slide, because I promised you 4 technologies, and we only had 2 so far. So we had tidal and we had wave. Another one, which is very interesting, is the ocean thermal energy conversion. As I said, this is a technology which is really well suited for the equatorial belt, for the more tropical areas, where you still have deep water. So, for example, islands, Hawaii as an example, or Bonaire, so the Netherlands Antilles. So this area where you have deep water, so you have very cold water in 100, 200 meter depth, and where you have warm water because of the tropical climate on the top of it, and then you can exchange the water flows and generate electricity out of it. And the nice thing about this electricity, it is baseload and it can be tuned. So this is like something which is continuously running your grid or running your electricity system, which is especially important if you go like off-grid solutions, if you go to islands which maybe cannot have huge installations of wind or solar out of space issues, or which cannot have huge storage solutions there. And on the next slide, we see also the installation of salinity gradient, which as well can provide base electricity. It can be tuned. I will not spend too long on salinity gradient because we have an absolute expert here, the founder of this company, who will talk to you in a bit about it. But also here we see technology which can provide us with continuous and slightly tunable electricity. On the next slide, we have a QR code where you can find a bit more to these technologies. We apologize, I think it's still in Dutch, but we will make also an English version of it. Because all the innovations I just presented had some Dutch contributions in there. So the made in the Netherlands. And as many of you know, the Dutch society or the Dutch community is known for the knowledge in water technology. And this is exactly the knowledge we are bringing to this sector as well, and helping them. I hope the QR code works. I see many people here trying it out, and I also hope online it works. But yeah, so the Dutch contribution to this sector is also an essential part, whether as a supplier or whether that the technology is really developed in the Netherlands. So everybody, okay, I don't see anybody scanning the QR code anymore. I can't see the people online, so I hope you also got it, but otherwise there will be a recording and the presentation. So let's go to the next slide. So I talked now a lot about the sector. What is the sector? We had the 4 technology types. We had a few examples of the sector. I'm also happy to discuss later on a bit more into detail because I went through them rather fast to show you all the amount what is possible. But what does DMEC do in there? So DMEC, the Dutch Marine Energy Center, which I'm representing here today, helps this technology to mature. So we're working with a full range of different technology developers, from concept to pilots to demonstrations, and we help them mature in their development. So this has many kind of different, so let's go to the next slide. This has many kind of different parts where we help them to innovate. So we help them to advance technologies and products, also to advance their business case. If the business case is not yet fully developed, especially often it comes from a concept phase from the universities, just launching their company. So then we really have to figure out what is a suitable business case, how can we get these technologies off the ground. And getting the technologies off the ground, it's offshore, so it's also not too cheap. So we help them raise capital, we help them raise public capital, but also private capital. So European projects, international projects, national projects, but also private investors. We help to shape in the Netherlands, and my colleague Sander also on a European level, or the OEE, this organization is helping them on a European level to shape the policies so that the policies are beneficial for the marine energy sector, because of course you would never had wind or solar if not the policies would have been beneficial for them. And the same is true for marine energy. You need, of course, this additional push from the policymakers, from the national and international communities and governments to get this technology off the ground, which is already happening, as we saw before. And last but not least, we're also supporting them in finding the right market. I mean, the obvious market to go for is the utility sector, so where you basically produce electricity, sell it to the national grid, and voila. But of course, there are different markets. So we're looking into also agriculture, so how you can power with these devices an agriculture farm. We're looking into how you can power oil and gas platforms, so electrifying oil and gas platforms. We are looking into all kind of port electrification, so how you can power your port with local electricity production, and many more of these things. So the market is also a very interesting and exciting part we are working on. And then let's go to the next slide. With all of that, we have currently 7 public-private partnerships ongoing with about 85 international partners in these public-private partnerships, and over 125 technology companies in the marine energy field, which we supported throughout this time, and raised 110 million euros in public and private funding for these projects to help getting them off the ground. And I think then to the last slide, or the second last slide, just last slide, we and the marine energy sector in general are, as you saw also in the video, open for business. So we are happy to link you to developers. We're happy to sustain the contacts and also to just inform you better and more what you can do in this sector, what you can do with this sector. And you can reach out to myself and to Sander, of course, how to install more marine energy in the Netherlands, in Europe, and the world. And with that, let's go to the last slide, where we also have to say a big thank you, because we are here today thanks to the Integraal North Sea Region program of OISA. And this project enabled us to give you this insight into marine energy and this talk today. And with that, I think we will also give the floor back to Sander and back to the next speakers. I think we do questions at the end, right?
That's right, Benjamin.
Yeah.
We'll do questions at the end, a short Q&A if time allows it. We have a very tight schedule, of course. So many interesting speakers. Thank you, Benjamin.
You're very welcome.
I really, give a hand to Benjamin. Thank you so much. And also, what I really enjoyed about this, within this context of being in the Dutch pavilion, is that all the technologies that you showed, all the solutions actually that you showed, had some. It might be a bolt, it might be a coating, it might be a research facility involved, but they all had just a little bit of Dutch involvement. So I think that really resonates here. And now I will give the floor to Peter Huck. He's doing something very unique. So I think he's the one best to explain it. But Peter, the floor is yours.
Yeah. Good morning. Next slide, please. Yeah, my name is Peter Huck. I'm the founder of a RedStack company. And please let me introduce my company RedStack to you. It's an impact scale-up working on sustainable water desalination and sustainable power generation. On the next slide, you see that our background is that we are a spin-off company from WETSUS, the Dutch European leading water technology institute. Our company is based on the results of many national and international research programs, and we have a strong patent position. We are awarded the title of Dutch National Icon by the full board of ministers a few years ago. Up to now, up to 50 million euro is invested in this technology, of which about 25 by WETSUS and other scientific institutes, and about 25 by our company ourselves. Next slide, please. In the energy transition, we are introducing, you all know that, various types of new energy, mainly based on sun and wind. They all have one problem. They supply the power. The supply of power is not continuous. It's often not even predictable. But it means no sun, no wind, no power. So when we would be depending on that, we would need to invest a large conversion and storage systems. And please let me introduce our technology, the blue energy technology, to generate sustainable and full continuous power. On the next slide, you see that the system is using fresh water and salt water with different salinities. And we're using two types of membranes. One where the positive ions pass through, one where the negative ions from the salt can pass through. These membranes are stacked alternately in a pile, we call it a stack. And the water flows, the fresh water, salt water, fresh water flows in between these membranes. What happens then is that the salt from the salt water starts to move to the freshwater side. But the positive ions, the sodium from the salt, only can pass to one membrane into the freshwater, to the one side. And the negative ions from the salt, the chloride, only can pass through the other membrane, the opposite membrane, to the other side. So it means all the pluses to the one side, all the minuses to the other side, a plus and a minus, that's a battery, a DC generator. And as long as the water flows through, we generate the power. And as long as the river flows, we can generate this power on a continuous basis. On the next slide, you see the power is generated 24/7. It's contradictory to the irregular supply and generation of wind and solar. So it reduces the need for expensive and inefficient conversion and storage systems. It can be harvested everywhere where the fresh and the salt water meet. For example, where the rivers flows into the sea. But also, on a bit smaller scale, it can be implemented in flood protection systems and pumping stations, but also where brines, very saline solutions, flow into the water, the surface water. And once fully implemented, it can generate up to 12% of the world power demand. It is tested by third parties like Dataris to be having no significant ecological impact. So it's low and is silent and invisible and not disturbing an eco-environment. On the next slide, you see that our pilot plant is running under real-life conditions at the Waddenzee in the Netherlands, using real surface water, fresh water and salt water. His Majesty, our King from the Netherlands, Willem-Alexander, has visited us and he did a ribbon-cutting ceremony at our grand opening a few years ago. On the next slide, you see that we are now upscaling, we're raising funds for upscaling our pilot plant facility into a demonstration size facility. And once this upscaling is done, you will see that the size of the stacks, the membrane stacks, will be the same at that plant as will be in the commercial industrial plants. On the next slide, you see that our process know-how, that's our core competence, but also the hardware, the equipment, the stacks, the membrane stacks, that is where all our know-how is incorporated in. On the next slide, please. We have been upscaling the stacks from a laboratory stack, with only a quarter of a square meter membrane in it, very small, up to stacks with more than 500 square meter of membrane in it. That's a factor of 2,000 times upscaling. And the good news is that during this upscaling, we found that we do not lose any efficiency. So per cubic meter of water used, per square meter of membrane implemented, the efficiency, the generation capacity is still the same. Our last step in upscaling what we have to do is going from the 500 square meter membrane in the stack to 2,000 square meter membrane in the stack. Only a factor of 4 bigger. We did already 2,000 times bigger. On the next slide. For the commercialization of this product line, we are now preparing the expansion of our pilot plant into a demonstration, as I just said. And once fully implemented later, and a while later, and a couple of hundred megawatts later, it is said that the cost price of our power will be very comparable with the cost price, the kilowatt hour price of solar and wind, the large modern project. But one big difference, our power is fully continuous available, so we do not need conversion and storage for that. And we are inviting power companies or EPCs to take a look at our technology and evaluate it for their territory, for their operating area. In the next slide, you can see that we're now also implementing our spin-off business. It's the same stack with the same membranes used for brackish water desalination. This technology as well, this concept is also tested, proven at the same pilot plant in the north of Netherlands. The key components, the membranes are the stack, are very the same. And the manufacturing process for us is the same. We do market this technology and equipment ourselves directly into the market of existing desalination plants to replace the available electrodesalination units after they're worn out. And we work with a special company called Pure Water Group for the new build project, an experienced OEM in this market. As a matter of fact, a little break, there's also another version of the desalination, the ED technology, called the EDI technology, also using stacks and membranes with some additional features. And this is used for the very far ultimate desalination of water, take all the salts out, make demi type of water, which is used for the hydrogen electrolyzers. These hydrogen electrolyzers need very pure water. So you see that this company is also contributing to the energy transition. Next slide, please. One other technology is once combining the desalination technology and the energy generating technology, the reversed desalination technology, you can make a battery out of it. Next slide, please. This battery is using only a batch of salt and water, nothing else. No toxic chemicals, no expensive, no rare chemicals, very simple water and salt. And the key feature of this technology is that the power capacity, expressed in kilowatt, and the storage capacity, expressed in kilowatt hour, or megawatt hour, I should say, is completely independent to be designed and operated. This technology is developed and operated and maintained and marketed by a company called Aqua Battery. And we cooperate with Redstack. Redstack will supply the stacks, and the other company, Pure Water Group, will supply the process equipment around the stacks. So these three Dutch innovative companies together are ready to make a contribution in the storage market. Next slide, please. So at the moment, we are offering dedicated investors to join us in boosting these technologies in the water desalination and the power generation applications. Oh, and the nice thing is, once we get a new investor on board, we immediately will get awarded a 4 or 5 million subsidy from the local Dutch governments to make a flying start or continue. Our revenues will grow pretty fast for the upcoming years based on the desalination technology. And once the large-scale projects, the 100+ megawatt power generation capacities systems are there, then of course the revenue will go sky high. Next slide, please. Our team is changing in the past. We started with a couple of researchers, technology development. Then we have process engineers. Now we've got the mechanical engineers, project developers, market specialists. So we are growing into the direction of a grown-up company. Last slide, please. So once you are ready to take a look at this unique opportunity to join us, to invest us in our company, and you're ready to make not only a contribution, but also a business in the energy transition, please contact us and feel free to talk about it. Thank you.
Thank you so much, Peter Hack from Redstack, and I think a very clear ask to find dedicated investors for upscaling this innovation. I'm now going to give you the floor to someone who's joining us from France, virtually. A warm welcome to Jean-Christophe Allot from working for Tucardo. You already saw actually a picture of the Tucardo turbines in the slides of Benjamin, and I think Jean-Christophe will talk a little bit more about all the other market opportunities that they see, but very exciting to have this title company with us today. So Jean-Christophe, the digital floor is yours.
Thank you, Sander. Good morning, everyone. I'm sorry I wasn't able to join you today, but I'm pleased to introduce you to Tucardo, a Dutch tidal turbine developer. Next slide, please. So our goal is to harness a safe and reliable hydropower driven by the gravitational pull between the Earth and the Moon to bring clean power to people and organizations. The company is fully owned by Hydroring and QED Naval, two long-standing actors in the ocean energy sector. This allows to provide an end-to-end service from early design to final marine operations. First development started back in 1999. After several tests, we moved towards a final design we are now fully working on since 15 years. The company owns 20 patents worldwide and accumulates more operating hours for its turbine than all our competitors together, which bring a major advantage to the sector. Next slide, please. Oh, sorry, I'm one slide late. Next slide. Yeah, thanks. So Tucardo is the sole actor to focus 100% on the turbine and only the turbine, while all the players are diverted by or reliant upon platform development, which increase development costs and problems to solve. The technology is a two-blade direct drive permanent magnet synchronous generator design to be simple and robust with low maintenance and installation costs. If we can start the video, you will see our best showcase is OTP. It's a project commissioned in 2015 in the Netherlands with 5 T2 turbines, 250 kilowatts power each. This project enables continuous product improvement and development. And if you have the opportunity to visit to come in Europe, we will be pleased to welcome you and visit this wonderful project. Next slide, please. So basically how it works. We have the combined gravitational pull of the sun and the moon on the water around the Earth. It implies a height difference as a result of the gravitational forces, and along coastline lines funnel and accelerate the water flow. The results of these two effects are the hydrokinetic energy or free water flow. As the tides change the direction every 6 hours, we adapt the technology to increase its efficiency. Tocardo's unique selling point is a smart reverse system or passive pitch, which enables to operate in opposite tidal flows without complex mechanical system subject to failure. Next slide, please. Yes, thanks. The overall tidal energy market worldwide is circa 500 gigawatts, with an associated annual global market of 53 billion euros. As you can see on the map, the key hotspots are located in regions with existing high energy demand, such as Europe or North America, or with very significant growing electrical need, like in Southeast Asia, for instance. Next slide, please. We rely on our design with 45 years of cumulative operation and our two partners, Hydroring and QED, to achieve first sales. The business is generating revenue since early 2021. We have more than 30 projects in the sales funnel. Main targets and contacts for now are in the UK, in France, in Ireland, in the Netherlands, and in Indonesia. Although the three competitive advantages of the solution is the low installation and operation and maintenance costs, the scalable and proven turbine design, and as previously stated, the 20 patents worldwide. Next slide, please. Our solution is 100% renewable, reliable, and predictable, contributing up to 6 sustainable development goals from the United Nations. It has been selected by Solar Impulse Foundation among the 1,000 solutions to fight climate change. We have made extensive environmental monitoring to prove our turbine to be fish-friendly as soon as April 2019. And we adapt our solution to fit your needs. We provide the turbine for sale, lease, or rent, together with operation and maintenance support. Next slide, please. So Tocardo only focuses on the power generation. We manufacture and supply turbines. We are only involved in the generation of the electricity. Next slide. So in more details, having this position in the supply chain, our business model only rely on the feasibility studies once a site is identified and preliminary resource assessment has been managed. We rely on consenting, permitting, and detailed engineering to adapt our turbine to selected support structure and sites. We do the whole procurement and fabrication of the device. And of course, we manage the monitoring and operation of the turbines while in operation. At the bottom left of the bottom right, sorry, of the slide, you can see a picture of the Inyanga Ensha DP2. Indeed, our partner Hydroring is a key asset regarding installation and marine operation. Inyanga acquired a multi-purpose vessel this May dedicated to the ocean energy sector. She will in particular work on all Tocardo's future projects to bring down the offshore operation cost, both during initial deployment and maintenance need. This is a key asset for the sector and for Tocardo, as previously for much operation, we needed to rely on expensive offshore oil and gas. And thanks to this acquisition of our partner Hydrowing, the CapEx and OpEx cost will decrease a lot. Next slide, please. We already qualified the turbine with 4 foundations. This turbine-only approach proves the efficiency to address different markets and to increase the business opportunities. Through our client and partners, our turbine can be deployed on floating structure, such as SIPSO, on the seabed, like with Hydrowing and Suburb, or on existing civil works, like we've already managed with the OTP project. Next slide, please. Regarding marketing and sales strategy, the maturity of the tidal energy sector leads us to focus on smaller projects in coming years, such as remote islands and industries in far-flung areas. To do so, Tocardo raised brand awareness and positioned itself as a credible solution to fight climate change on a local level. In addition, Tocardo has built several significant and strong partnerships within the sector, in particular with the Dutch Marine Energy Center and the Delft University, 2 strong partners and support to grow the business. Next slide, please. As a conclusion, I hope you are now convinced of the accuracy of our solution and the strengths of our company. We'll be glad to welcome you in the Netherlands to visit our facilities, meet our executive board, and witness OTP with its 5 24/7 operating turbines. Next slide, please. Thank you very much for your interest in Tocardo, and I will be pleased to answer any question you may have at the end of the session or later on by email. Thank you very much.
Okay. Yes, I'll give a big hand to Jean-Christophe Allot from Tocardo, and please, he will stay with us online to answer any questions that we have at the moment. Peter Huck from RedStack and Benjamin Lehner from DMEC will also be here present. Maybe I can invite Peter, yes, to the stage. If there are any questions, perhaps from their own business side perspective, to have a technical question, that's perfectly fine. A more random, how do you see the future question is also perfectly fine. After that, we'll have a short video on something that will make all the presentations you just saw even more tangible, because we have a VR experience. Unfortunately, this is only for the people physically present here at the Dutch Pavilion during this Dubai World Expo. We have those VR experiences over there, but we'll show a bit of a teaser in 10 minutes. So yeah, if there are any questions, I would like to get a show of hands, and my colleague Astrid, who I'd like to thank also for help organize it. It's been incredibly important in the run-up to this event, so thank you, Astrid. But
maybe for the people online, you can also ask questions in the chat function. So we also take the questions online, of course, so please just ask there in the chat and we will be with you.
Thank you, Benjamin. Yes, that's indeed true. You can just type something in the chat and we'll be able to answer that as well. So is there anyone who has a question? Yes. And please introduce yourself as well.
Yeah, my name is Robin Morelis, Deltaris, and thank you for the interesting presentations. Very good to see that. And well, Peter already mentioned that there has been some review on possible ecological effects of the use of RedStack or similar technology or OTEC. So I'm wondering, with the residual flow, the brine, actually the smaller brine that you have as a rest product of your process, which is being discharged back into the sea, obviously. How do you deal with that so that it doesn't have that impact? Because you're combining, in this case, Ice Lake water with North Sea water. Where would you be discharging that? And with OTEC, I saw already that you put that halfway the water column, so I can start to understand how you do that. But mainly also in relation to the figure you showed that it could account for 12% of the global power usage. How much of an effect would you have on the ocean stratification and the natural basic gradients in salinity?
Okay, thanks for the question. I'm afraid we're a bit mixing up things. The brine discharge is a result of the water desalination process, and there's it's the same thing. Any type of desalination process generates a brine. The question is, what do you do with it? And regardless of the technology, a concentrated brine normally is discharged in the sea, but it would be more clever to try to combine it with a freshwater flow flowing into the sea. For example, the treated sewage from the lowest sewage treatment plant, in many countries that is also discharged in the sea. Mix the brine with the treated sewage, and you have about seawater concentration level flowing into the sea and generating energy. When you compare to the large-scale application of a power generation plant, where the river water is flowing into the sea, it's flowing into the sea anyhow. We are at the very last one using the fresh water, so we are not competing with irrigation water, with drinking water, with processed water, nothing. We only take the fresh water in the river just a second before it is discharging in the sea anyhow. And there basically we are pre-mixing the water. So we change nothing. We do not add any chemicals or change the salt load. We only harvest some power out of it.
Thanks. Good.
Thank you.
Yeah, I do hope your question is answered. And as you can hear probably from this question, we have a lot of expertise in this room. I already see a raise of a hand for another question, or yes. And please introduce yourself.
Yes, my name is Bob Sorensen. I work together with Skyne Connect, which is a local company linking Dutch European companies into the region here. Thank you also for your presentations. What I really wondered is, your solution is very attractive if you compare it to the standard large wind farm parks. I mean, out at the sea, it kind of clutters the horizon. There's lots of social issues with that. Your solution doesn't have that problem, doesn't seem to have that problem. How come it has not been picked up sooner?
Yeah, that's what I'm wondering sometimes as well. It's a good question. Well, the problem is that our company, or the Wetsuit Institute, and our company are leading in the world. We are the first ones to work on it. There is an institute in Korea working on it, but there's only government. There's no company involved. And that's also a problem for us, because we are developing a market that isn't even there yet. So we have to do in Dutch zendelingenwerk, I don't know the English word for that, to make public awareness for it. And that's a hell of a job. And this, for example, a stupid thing is, in a country like Korea, which would be a great export market, their energy from water is not having the definition or the approval of being sustainable energy, renewable energy. It's sun and wind over there, but energy from water is not recognized as sustainable renewable energy. So a lot of public awareness and lobbying is needed to do that.
Thank you. Just, if I may. Yep. So that public awareness is kind of the same thing of what the other guys already did decades ago to provide clean energy. Now this is just an add-on in that kind of green energy solutions portfolio. And I would reckon that if you could get bigger coverage on that it would be a serious competitor versus some of the other solutions. And at what scale? I mean, you started from the Netherlands. I think the European Union is a very good body for that. I'm quite sure you already talked to lots of people over there. Maybe bring it up a next level at a United Nations level, because it's so, as is what I can see, I mean, there's not a lot of impact on the local environment where you can set up the plant. There's not a lot of discharge, and it seems to be very highly efficient, even when you scale it up. There's little waste.
Yeah, I guess you're right. I hope you're right. I think you're right. But we are an SME. We are technical guys bringing a technology and a technical solution into the market, and all this higher level political strategic stuff, that's new for us. So we're very happy that we have people around like DMEC who can help us in making this public awareness. I'm very thankful that I'm allowed to be here to present it. It's one of the steps we have to do to get this public awareness.
Thank you for the questions, and I already see raise your hands for the next question. So yes, thank you. Please introduce yourself as well, so that also the people.
Hi, my name's Kathleen Swalling. I used to be the senior lawyer for the Great Barrier Reef, and then ended up managing about 7 TV islands for them. So we actually implemented the first climate neutral island on Low Isles off Port Douglas. And then if you look, there's another island called Lady Elliot Island, and they're using a lot of they're always trialling new energy solutions, basically. I'm just thinking about your capacity to promote, and I'm certainly not big business at all, but I've managed to get profile for these locations which have been quite profitable for them. And I'm wondering if you looked at working a pilot case somewhere that was sensitive, high profile, high visitation, and shared the numbers quite simply in terms of, I mean, it looks fantastic. I don't know, what the science says about the outcome for the corals and the fish and blah, blah. But that might be an opportunity for someone to profile that. So then, yes, maybe.
Yeah, thanks for the suggestion, and maybe after this meeting you can explain a bit more what we're supposed to do. Yeah. Good, yes. Good. So thank you.
Yeah, sorry, you don't have a microphone, so the people online will probably not be able to hear this, but I think, definitely some interesting connections here, and unfortunately this will not be the case for the people online, but the people physically here will have an hour of networking, talking, so we'll have plenty of opportunity to discuss synergies. I think we have time for one last question, and I already see someone with the microphone.
Yeah,
so
sorry
please.
for stealing the last question there, but my name is Teun Kopersen. I work for DMEC, the national oil company, and we try to localize through DMEC procurement and through partnerships new industries and new technologies into the UAE. So my question is to anyone here, to what degree are you making inroads into investing in the UAE already? And of course everybody thinks onshore solar is the most obvious thought, but the UAE takes a lot of offshore energy in terms of oil and gas, and there must be a lot of opportunities here. Are you looking into that? Have you made any inroads into that already?
Yes, sorry. I think both can answer this question. Maybe
three, I think.
Benjamin first. Thanks.
Really good question. I think there is quite a lot of opportunities also how we can work with the UAE and on that side. We see just now that more extreme climate is coming, so like coastal protection integration, if you have dams, if you have protection, like coastal protection installations, of course Torqeedo would be a great partner if you also say, okay, we don't just protect the coast, but we also electrify the coast with this technology, and that could be and I think Jean-Christophe can say a bit more about that. But also, just in general, the streams on the Gulf of Oman, there are possibilities there. And going a little bit further, so if you go to the Indian Ocean, then you have also great wave climate. So there are a lot of opportunities, and it really needs to be looked at on a case-to-case basis, especially if you electrify platforms. There are, for example, integrated solutions where you have solar plus wave in one device, which actually also has a battery in there. So there's a French developer doing that, which can be directly installed to an oil and gas platform and provides continuous electricity. So there are these solutions already out there, and we are happy to also link you and the oil and gas sector in there. But before I tell everything, I think maybe Jean-Christophe for the electrifying infrastructure, do you want to add something there?
Yes, Jean-Christophe. I don't know if you heard the question, but what are the opportunities here in the region and maybe also the wider region? Because I do believe it's quite a large company that focuses on quite a large area.
Thank you for the question. I totally agree with Benjamin that there is a lot of opportunities to develop these sectors, both in the EU and outside of the EU. And companies such as Torqeedo are always looking for new partners, both industrial partners and financial partners, either for corporate investment or for infrastructure investments in specific projects. So I will be very glad to speak with the guy from DMEC. I didn't see him online, so feel free to send him my contact details, and I will be very glad to pursue this conversation with him, because if he's looking for opportunities, we have some to propose to him.
Okay, yeah, my pleasure, please.
Yeah.
Great to hear. Maybe closing remark.
Just to add on, My last business trip 20 months ago, just before the Corona stuff started to happen, was in Abu Dhabi and Dubai. And we were working with the first leads with Kuwait, KSRI project, on a brine discharge and sewage discharge into the sea to try to develop a project. I was at ADNOC, talking about the produced water desalination and recovering of the nutrients, but then the oil price dropped. I was in contact with DEWA, not only for desalination, but also for the storage technology. And then Corona came along. So yes, we're focusing on the area. Although the first impression might be there is no river here, so why would you be talking about blue energy harvesting for rivers? Yes, but there are also, let's call it niche market, dedicated suitable applications, and we'd be happy to pick up where we left it 20 months ago.
Many opportunities. I see. I think I'm gonna close it off because we also have a video that we want to show that will be like a teaser for the virtual reality experience that we have here for the people who are physically present. I would like to thank all the speakers. First of all, I think it was all very inspiring, and I think a lot of connections will be made here today. I also want to give thanks to the organization. We've been very grateful, also in the run-up to the experience here, on the level of professionality. And the warm welcome that we received. Yeah, it's definitely for all the people, and I'm now talking to the camera, who haven't joined. Yeah, this Dubai World Expo will go on for a couple of months. The weather will be even more comfortable in the next few months, so do visit, and definitely visit this platform because it's quite a unique experience. And then now I would like to ask the technical people who've been great, very fine as well in helping us to put on the video. Thank you.
Thank you.